So we're on page 14, and we just drew our complex plane. Remember, on the horizontal, this is the real axis. This is the imaginary axis. So looking at number 1, 2i, it's got to be in form a plus bi. What would be your a in this one? 0. So you would graph it as like if you were graphing 0, 2, okay? So I stay at my origin, and then I just go up how many? 2. And I'm just going to label this point, and I'm going to put number 1. Or if you want to make it letter A, that's fine. But that's number 1 graph right there. Number 2, 4 plus I. Go over 4, up 1. That is number 2. We're going to graph them and then come out and find the modulus, okay? Number 3, 8 minus 5i. So I'll go over right 8, down 5i. Number 4, my a is what in this problem? 3, my b would be what? Because remember, a plus bi, a is your real part, so you graph in 3, 0. So I go over to 3 and do not move. That's that. Number 5, square root of 2 plus 3i. You need to find a decimal reference. What's the 1 point what? What is the square root of 2? 1.7? 1 point what? Okay, so let's go like 1.4. We're going to estimate. Little past 1, up 3. Number 6, negative 4. I'm going to go left 4. Now, we need to estimate, divide negative square root of 3 by 3. What do you get? Negative 0.57. Yes. So about negative 0.57. So you're just going to go somewhere right in here, halfway between 0 and negative 1. That's not too bad, is it? That's how you graph complex numbers. Now we're going to go back and find the modulus, the absolute value, and that is using the symbol z in absolute value equals a squared plus b squared. My a is what in this problem? 0. Square root of 4 is 2. Like you can look at this one and tell, since it's the only number is 2. So what's the absolute value of this one? 3. You don't have to show your work on that. When it's like that, you can do it in your head. Square it and take the square root. It's going to be 2.
Can you do plus and minus 2?
No, you don't have to do that on this now. Because its absolute value is distance. It's going to be positive. Alright, 4 plus I. Square root of 4 squared plus what? 1 squared. This would be 16 plus 1, so it would be square root of 17. It's the modulus. Yes, because the formula is the absolute value of a squared plus b squared. A is your real part, b is your imaginary. I'm not going to give you those formulas on test, so you got to know these by heart. Alright, that's going to be 64 plus 25, which is 89. You cannot break that down. Number 5. Square root of 2 squared is 2, plus 3 squared, that's 9, square root of 11. Number 6. Negative 4 squared plus square root of 3 over 3 squared. Don't let that intimidate you. Let's say that's going to be 16. Just square the numerator, square the denominator. Square root of 3 squared, that's going to give me 3 over 9. Be 6 square root of 16 and 1/3. Because 3/9 is 1/3. I'm not going to give you something like that on an exam, but you can just leave it square root of 16 and 1/3.
What do you do for
Number 4, square root of 3 squared plus 0 squared equals 3.
Wouldn't it be square root of 3? Oh, never mind. Yeah.
Okay. So our first 2 learning targets were I can graph a complex number and I can find the modulus. Are we good on those? All right. Here we go. We're going to write complex numbers in polar form now. Okay. Okay, given a complex number, a plus bi, that's a complex number. This is its polar form equivalency, okay? You see an R, parentheses, cosine theta plus I sine theta. The R is your modulus, okay? So the modulus goes outside this parentheses. Every complex number has a polar form in which it's a modulus times a parentheses. So the modulus goes on the outside plus, parentheses. This is how I remember. Cosine always goes first. Okay. A comes before B, don't it? Doesn't C come before S? So cosine goes first. You're going to have cosine, some angle, and I'm going to teach you how to find the angle, plus always I sine the angle, okay? So modulus, cosine, there's going to be an angle there, plus I sine, there's going to be an angle sitting there. It's going to be the same angle, but you just got to find it one time, okay? So that's what we're doing now. So on number 1, the first thing we're going to do is find our modulus, okay? So 1 plus I, 1 squared plus 1 squared is square root of 2. So we found that. Now, this is where, don't we always, if we can look at a quadrant, we want to know it up front because it helps you out. If I was to graph 1 plus I in the complex plane, it'd be like graphing 1, 1, wouldn't it? What quadrant is that in? 1. Okay, you need to remember that. Now, tangent. What's the definition of tangent? Okay, this is how they tell you to find the angle. Tangent theta equals b over a. There's so many different formulas. I just remember this. In this, if I was to graph this, just think of it like the regular plane. Wouldn't that be your x coordinate? That'd be your y coordinate. So instead of learning all these different formulas like b over a, y over x, just pretend that's your y. 1 divided by what? You see that? So 1 divided by 1 is what? Does that make sense? So tangent of theta equals 1 divided by 1, which is 1. What family gives you a tangent value of 1? Which power 4 is in quad 1? So your answer is the square root of 2 cosine of pi over 4 plus I sine pi over 4. There's your complex number in polar form. That's your answer. Yes. So that's it in complex form. There's it in polar form. Square root of 2 times cosine of pi over 4 plus I sine pi over 4. Looking at number 2, negative 1 plus square root of 3 of I. If I was to graph that in the complex plane, what quadrant would that be in? 2. So we need to put quad 2. Let's find our modulus first. Negative 1 squared is 1, plus 3, square root of 4 is 2. tangent of theta equals, what would I put on top? Root 3 over negative 1, which is negative root 3. Which family gives you tangent of root 3? Pi over 3. Pi over 3. Which pi over 3 family members in quad 2? There's your answer. So you put 2 cosine 2 pi over 3 plus what? I sine 2 pi over 3, and that's your answer. Keep going. Number 3. If I was to graph that in the complex plane, what quadrant would that be in? Quad 3. Quad 3. Okay, find the modulus. That's negative 4 square root of 3 squared plus negative 4 squared. Let's see how we handle this. Negative 4 squared is 16. 16 times 3 is 48. Do you see how I got 48? I square the 4. The square root and the square cancel out, so that's how you get 48. Plus 16, which is square root of 64, which is equal to 8. Tangent of negative 4 divided by negative 4 root 3. These cancel out. You left with 1 over root 3, which in turn equals what? Because you rationalized. So you have to think, okay, what family gives me a tangent of root 3 over 3? Pi over 6. Which pi over 6 is in quad 3? There you go. And there's your polar equivalency to that complex number. Why do you think 4 and 5 is on this example? Because they're not in a what? Quadrant. So when you talk about how you have one that's not in a quadrant. Actually, these are very easy, very simple. You can look at both those. Number 4. What's the modulus for number 4? 6. Okay. So we're going to put 6 down. 6 parentheses cosine. If I was to graph 6i, it would be 0 up 6 with. What angle is that? Pi over 2. This stuff is not hard. You just gotta look. Each night you need to review it, so you say, okay, this is what you do when the instructor asks me for this. You just gotta remember all this stuff. Number 5, negative 2. If I was to graph that, that's as if I'm graphing negative 2 zeros. So I'm going over here. What's your modulus for this? 2. So you put 2 down. What is over here? Pi. And that's my answer. How do y'all feel on that? I need a hand signal. Alright, last thing we're going to do. Multiplying and dividing the complex numbers is real easy. Last 2. We want to multiply Z1 times Z2. And here's your 2 complex numbers in polar form. How do you do this? You multiply the outside modulus. What's 2 times 5? 10. What do you think we do with these inside things? You add those. You multiply the outside and you add this. So pi over 4 plus pi over 3. Common denominator is 12. Be 3 pi over 12 and... So what did that add give you? So it'd be cosine 7 pi over 12. And that's your answer for the multiplication. Now I want to divide Z1 by Z2. So I multiply them, now I'm going to divide them. You divide the outside numbers. What's 2 divided by 5? 2/5. You can't do anything with that. What do you think we do inside now? Subtract. So that's 3 pi over 12. So this would be negative pi over 12. And that's all you do for these. So number 2, we're going to multiply square root of 2 times 3 square root of 2. What would that give you?
12.
First of all, let's do square root of 2 times square root of 2. What is that? 2. 2 times 3 is? 6. Yes, Tyler?
So do you always find a product and the quotient?
Mm-hmm.
Specify?
It's unspecified, but I'm going to say both of them each time. I'm going to add those inside. 75 and 60. It gives you 135. Yes, it's going to be the same numbers. Like you only have to add it once and put the other. I mean, add it once. I know 135 is going to go there. Z1 divided by Z2. That's square root of 2 divided by 3 square root of 2. These cancel out. So I'm left with 1/3 cosine of 15 plus I sine of 15. And that's your answer. So please take the night to start reviewing everything, looking over your graphs, looking over these notes, because tomorrow is when this turns a little difficult. When we start finding, like this is what we're doing tomorrow, like finding 1/2 plus 1/2 I to the 10th without having to multiply it all out. Like here, instead of multiplying it out, we're going to be able to do a formula to find all that. And then leading on to, in a few days, you're going to find me the cube root of that. Find the 6th root of that. Find the square root of that. So it just... Yes. Now, I'm going to be kind and turn this to page 610 if you want to take a picture today, if you have some time today. But this is the only day I'm going to do this. You need to bring a book to class every day this week. So page 610 is right there.